A beam of white light is incident normally on a plane surface, absorbing 70% of light and reflecting the rest. If the incident beam carries 10 watt of power, find the force exerted by it on the surface. We'll see this question. If a light is incident on basically normal incidence is given, let us say this is the surface. It may be any surface, not completely reflecting surface. So like you can assume like this also, like this. Yes, you can assume like this also, like that is the surface. Yes. Okay, but here can be absorption also. So let us suppose the light is incident like this. Normally this is incident, and number of photons are dn upon dt. So it is here mentioned that 70% of light on a plane surface absorbing 70% of light. Let us suppose absorptivity is given to be 0.7. So reflectivity that will write will be 0.3. It means of 100%, that is the total number of photons falling per unit time, 70% means 0.7 part is absorbed by the surface and 30% is reflected back. So when, let us say these photons are coming and when they are getting reflected like this, let us say these are getting reflected, so what will happen, the change in momentum in case of reflection is 2h by lambda, and change in momentum in case of what absorption is h by lambda, because some photons are coming and which are absorbed by the surface. That's why there is no finally they are getting no momentum. Understand? Because they are coming with h by lambda, but finally they don't have e. They are absorbed here. So here you got, and that will basically we are writing what pf minus p initial. So if you write here similarly, we are writing the final is 0 and minus, and that minus sign because that is falling downward. So h by lambda. So finally we are getting h by lambda. Now you see the total momentum change for, that is a total momentum change for reflection, we have to multiply what number of photons, is it or not? So if you multiply the number of photons means that is the dn upon dt. Okay, and we are calculating this what per unit time, so dn upon dt, and that is 2h by lambda, but only 30% are reflected, is 0.3 part, 0.3 part is only reflected. Here again we'll write dn upon dt, you see, and the change in momentum. So change in momentum is what h by lambda, and that is a 70% means zero point 0.7. So you see, if you do this, basically that becomes the total change in momentum per unit time, because that is the reflective part and that is the absorptive part we have written here. Okay, so that is nothing but that is the force change in momentum per unit time. So if you see here, we can write f is equal to dn upon dt, and we don't know the value of lambda basically, so we can take h by lambda common from here. Okay, and so we are remaining with what 0.6, and that is 0.7. So we can say the force is, this is 1.3 dn upon dt times of h by lambda, and we'll consider this equation first. Now the power is given here, power is given here, that is 10 watt. So we know that what we are writing, we're going to write the power, that is hc by lambda, and that is dn upon dt. Okay, that is the energy, and energy per unit time, that is the power. So you see, the value of power is given to be 10 watt, and dN upon dt, we don't know. H by lambda, we have to make it constant because we need here in the first equation, and just take C here. C is the speed of light. So it means this complete term can be replaced with this. So we'll find the force from equation first and second. So we can write what force, that is here. You see, just put the values 1.3, and this is 10 by C. 10 by C, that is 3 into 10 to power 8, like this. So here you see, you will find, you multiply this. So 13 divided by 3, that is 10 to power minus 8. Just complete the solution. This is 3 4 is 12, and this is 2.5 into 10 to power minus 8 Newton. So that is the force exerted. So you can write this approximately 4.3 10 to power minus 8 Newton. So that is the force exerted by the photon on the light, on the surface. Thank you. Thank you for watching.